Hi everyone, in this video we're going to discuss our Mid Sem Test. So for the question number 1, show that the equation 2x equals to ln 3 minus x has a root between x equals to 0 and x equals to 1 by using Newton-Raphson method and taking the first approximation as 0.5, find the roots correct to two significant figures. So firstly we get this equation. So we need to show that there has a root between 0 and 1. So from the equation, we build out the function for 2x equals to ln 3 minus x. So we move it to the left-hand side here, let it to be 0. So we define our function as 2x minus ln 3 minus x. So of course you want to move it to the right hand side also can become ln 3 minus x minus 2x. So that function also acceptable. So once we get our function, we try to show out the equation have the roots by using algebraic method. So algebraic method will be substitute the x0 here. And we see the y value here, or function value, which is negative 1.099 negative. And then we substitute another x value given, which is 1. We get 1.307, which is positive. So you can see our y coordinate here, one is positive, one is negative. So let's say your y coordinate, one is negative, means below x-axis. Another coordinate here is positive, so above x-axis. So when these two coordinates have changing sign, which means that the function will touch x-axis at least at one point. So there maybe they have curved down and curved up. We're not sure. But from these algebraic methods, as long as the y coordinate have a changing sign here, we can say this equation have a root between x and 0 and 1. So after we calculate this, we need to show up, means we need to come out the conclusion, what do you have here? So we can say since f0 is negative and f1 is positive, and there is a opposite sign or changing sign, therefore we can conclude here that exists at least one root between the value give here. Between the value give here is x equals to 0 and x equals to 1. Then we proceed this question. They say, by using Newton-Raphson method. Alright, so we come up with the Newton-Raphson formula where Sn plus 1, it will be equals to your Sn and then minus our function in term of x and our differential function in term of x. So our functions here is 2x minus ln 3 minus x. We need to find out what is your differential function. So to differentiate 2x, we get 2. To differentiate ln, we get down the ln here, 3 minus x, and we differentiate it at numerator. Differentiate negative x, we get negative 1. So our differential function is 2 plus 1 over 3 minus x. Then we can start calculate. Plug into our formula with the x node given here. First approximation is 0.5. So for the next x, so apply this formula. For the next x means you take x node minus the x not in term of function. So substitute here. Make sure you write the full working to show us how you substitute your value. And differential function 2 plus 3 minus 0.5. So calculate out what is your x1 answer. By using our calculator, we can plug in the formula. Let's say alpha x minus the fraction, numerator 2 alpha x minus ln 3 minus alpha x over denominator is differential function where it will be 2 plus the fraction 1 over 3 minus alpha x. Then we press for calculate to evaluate the first approximate, which is 0.5. So here we have our answer 0.46. So how many decimal or how many significant figure we need to take? Your final answer correct to 2 significant figures. In calculation, we can accept extra 1 or extra 2. Maximum we accept extra 2 significant figure to be the answer. Alright, so in working we must have extra 1 or extra 2. So if here is 2 significant will be 4, 6. Maximum significant figure we accept in calculation is maximum 2. So you can put your answer in 4, 6, 5, 3 significant we accept, or 4, 6, 5, 1. That is the maximum significant we can accept in the calculation. So not more than that. If you have getting more decimal at the back, then you don't have your stopping criteria where you cannot meet the value of x in repeated way. You cannot get your x repeated. Alright, or your calculation iteration will be extra than people. So people do for 3 iteration can get the answer, but when you get more not suitable decimal or significant, and then you get up to 4 or 6 iteration, then only you get to the final. So which means that you don't know your significant figure will affect your stopping criteria. Alright, so here, as long as you extra 1 or extra 2 in your working, that will be safe. So more than that will not be the safe working already. You will need to calculate more than that. You will be out of your answer scheme. Alright, so after we get this first iteration answer, so first calculation answer, we go to secondly. So secondly means we need to repeat the formula for this Newton-Raphson formula. Value of x minus the function in terms of the value of x that you substitute over the differential function. So for the second working, we can write it in short in terms of f, but for the first working, we require you to write in full. We want to see what is your value of x in your full functions here. So to get this, so this is your first iteration. To get this second iteration result, we just press calculate again for the value that you use for 651 and equal. So 0.46508. So you can see this is 08. We round off because we get 51. So notice here, we have repeated x, which means that our iterations should be stopped after 2 iteration or 3 calculation. If you start with x1, x2, x3, you're supposed to get your answer and you're supposed to stop already. When your x is repeat, means your stopping criteria is achieved, then we can start to conclude up the final answer. The value of x, which is your roots here that you need to find in the rounding correct to 2 decimal. So this is for us to round off to final answer 2 decimal, no, 2 significant figure. It will be 465, round off become 47. So that's all for these questions. Alright, so we see what is important here. Firstly, we are testing you on algebraic method, showing the roots. So substitute your first value, and then substitute your second value, and then you come up with the conclusion. And then we go for the Newton-Raphson formula. Of course, we need our first derivative function. So differentiate your function to get correct to your function. Once your differential function is wrong, means your whole Newton-Raphson method concept will be out of the scheme. So it will be not accepted. And then we try to see how you get your first iteration, means how you get from the initial value to the first calculation. Here we see your working, and we see your answer. Is it acceptable? Is it you know how many decimal or how many significant that you need should be put here? So here 2 significant, we accept 465, and also we accept 4651. Other than that, we not accept anymore other values. Then we need to see, do you know how to stop in the second x? Because this question, when you put your second x, you do your second calculation, you do your second iteration, you're supposed to stop already. You will get your repeated x and conclude out that is your x value. So that's all for these questions. Let us continue to the second questions. So for this question, they ask us to evaluate this integral from lower limit 0 up to upper limit 2 for the function x times with the square root 2 for 5 minus 2x respect to x using the suitable substitution. So they require us to do substitution method, which means that you must know what to start with, what is your u to be start with. So you can see this function in multiply. Choose the complicated one. So choose the function with the power, which is 1 over 2. So u will be 5 minus 2x. So this one, you change it to u already. Substitute with u already. So supposedly we need to substitute all these x, dx, upper limit, and also lower limit. So to get x dx, we differentiate u. With respect to x, we get negative 2. Then we do the cross multiplication. We can notice that the dx can be substituted with negative 1 over 2 du. So this is the first part, this is the second part. So this part we substitute with negative 1 over 2 du. One more part, x. So x, it can be substituted by rearrange the u expression equation here. So negative 2x equals to u minus 5. So x will be equals to, so I move u over 2. So simplify the negative and I rearrange. Then your upper limit, when x is equals to 2, what is your u value? Which is 1. When x is equals to 0, what is your u value here? It is 5. Then we can substitute this integration in terms of u. So start with the lower limit, substitute with 5. Upper limit, substitute with 1. For x term, substitute with y 5 minus u over 2. For this square root, substitute with u power 1 over 2. And this dx, substitute with negative 1 over 2 du. So all this in multiplication. And then we're going to integrate this in terms of u. So simplify first. Take out our constant, which is negative 1 over 4. So you can see 1 over 2, 1 over 2 in total, multiply together, 1 over 4. This one, 5 minus u times with u power of 1 over 2 du. Let us simplify that. Expand it, you will get 5 u power of 1 over 2 minus u power of 3 over 2 du. Then we can start integrate. So integrate this will be power plus 1 over new power. So 3 over 2. This is 5. Minus again power plus 1. 5 over 2. So 5 over 2 is the 1. You flip up the 2 up. And upper limit is 1. Lower limit is 5. For the next procedure, substitute upper limit minus lower limit. So substitute this u in terms of 1 because we already changed the x value in terms of u, in terms of value of u. So substitute this upper limit as 1 in u here. Just make sure you write the working correct. Substitute your lower limit 5. And then evaluate using your calculator. So when you want to evaluate using your calculator, you can try directly press this using your button, which is this button. Seek for this button, key in your lower limit, upper limit, key in your function. So if you don't want to key in with this, you can key in with the function that you already simplified. So at last, we get our value. So which is 2.993. Then we see what is important in this part. So firstly, you must know how to select your u correctly and differentiate it to find your dx, to find your x, to find your upper limit. So we need your integration all in terms of u. So we will see here. Is it your limit? Substitute in terms of u. Is it your function? Substitute in terms of u. Is it your dx? Substitute in terms of u. Then only you start integrate and show us upper limit minus lower limit to get the defined integral here. So that's all for this. Then we move on to the second question here. Consider the region bounded by the curve reciprocal graph, and then y equals to 3 and x equals to 1 and x equals to exponential value. Show that the area of this region is 3e minus 5. And then find the volume of the solid of revolution when this region is revolved 360 degrees about x-axis. Leave your answer correct to 3 decimal place. So reciprocal graph, we sketch out this. So this is your reciprocal graph where x is not equal to 0, y not equal to 0, asymptote happen at x-axis, at y-axis. Y equals to 3 is a horizontal line. And x equals to 1, x equals to, so you can see x equals to 1. So when x equals to 1, this is 2 over 1, which is 2. So it will be here. X equals to 1 and x equals to e. So find the region bounded first before you calculate your area and volume. So we cannot simply answer area and volume question without drawing the graph, without knowing the region. Alright, so that is the huge mistake we receive where students like to integrate straightforward without knowing the graph, without knowing the region. So when I see this x equals to 1, y equals to 2, so I know that this is the x equals to 1. And then x equals to e is 2 point something, so more to the right hand side, which is the region bounded by this 1, 2, 3, 4. So 1, 2, 3, 4, it will be located at here. This is the region that we want to find for the area, for the volume. So you can see this region, if you want to calculate it respect to x, so I draw it vertically. I will calculate respect to x. You can see this region is not attached to x-axis. So which means that this region is under two curve concept. It is beyond x-axis. Alright, it is not attached. So two curve concept, a curve above it minus the curve below it to find its area. So area formulated from the lower limit vertically, we see this, which is 1. Upper limit is e. Then the curve above it, which is y equals to 3, minus the curve below it, which is y equals to 2 over x. Integrate this respect to x. So write your formula correctly, then only we start doing integrate. So integrate 3, we get 3x. Integrate, so 2 we take out. Integrate 1 over x, we get ln x. Upper limit is e, lower limit is 1. And the next step is substitute upper limit minus lower limit. And we figure out what is the value here without pressing calculator, because they ask us to show this is 3e minus 5. Show it one by one, where ln e will give us the value of 1. This is minus 3. This is ln 1 is 0. So 3e, negative, negative, positive here. So minus 3, then plus 2. Oh, sorry, this one minus. This one, ln 1 is 0. So here we have minus 5 unit square, where we managed to show it. And when we move on to the next questions, for the number 2, finding the volume using the same region also means that this volume is using two curve concept. Volume, formula pi. So limit is same, 1 until e. So two curve will be curve above square. So it will be fx square minus gx square dx. Integrate for volume. So fx square, which is 3 square, minus lower curve here is 2 over x square dx. So it is not the mistake we can see student doing fx minus gx square. This is difference. So fx minus gx square, you can come up fx square 2gf, then gx square. That will be difference equation already. Alright, so we come back to here, fx square, the curve minus the below curve square. Okay, square independent one by one. So we expand this first. This is 9. This is 4x minus 2. We move up when you x minus, when your x denominator is not negative 1, we will move up, become x power of negative 2. So only 1 over x will remain it in fraction to integrate in the fraction form. So continue. Integrate 9, we get 9x. This one power plus 1 over new power. And we simplify this. It will be substitute upper limit minus lower limit. So negative, negative, plus 4 over e minus and lastly, when you want to figure this, you can directly press your calculator. So leave your answer in 3 decimal place. So not leaving in the pi value or fraction value. the question requests here round off to 3 decimal place. So it will give us 40.640. Volume, unit cube. Then we see what is important here to answer area and volume. Firstly, you have to formulate your area equation correctly. How you use your integration. This bentuk must be betul. Bentuk to find your area must be correct. Then only we see how you start integration. To do this integration all correctly, then we accept for the next step how you substitute your upper limit and show it to this 3e minus 5. Then when you're doing volume also same, the first one is the basic for forming the formula, forming your volume formula using your function. Then only we start to see how you perform your integration correctly and substitute your upper limit minus lower limit, and final answer follow the restriction given from the question, which is 3 decimal place only. Alright, so this will be our second question. We move on to the third questions. So for the question number 3, obtain the general solution using this. So firstly, why I identify it becomes simplest while we're using integrating factor. So you can see, calculate this. Can you factorize your y, or can you factorize out your x here? So if you can factorize out your x or factorize out your y, which means that the question is using separable method. But y plus x, how we factorize? We can't factorize this. So when we cannot factorize this, we move on to our integrating factor method, which is simplest. S standard form. Start with dy dx, and then the term of y, and then equal to the right hand side the term of x. So rearrange to that form. Without that form, you can't get your px correctly. So our question dy dx, try to simplify this division, x dy x1, y dy x. So the term of y, when you want to move it to the left hand side, is supposed to 1 over x times y equals to 1. Therefore, your px is negative 1 over x. Why we want to get px? In our integrating factor formula, vx is equals to e integrate px dx. So to apply that, it will be e integrate negative 1 over x dx. Negative we take out. When we want to integrate 1 over x, you get it ln x. So can we just cut out the e and ln? No. Alright, so simplify by using your logarithm properties. The coefficient, the x, move up to come power, then only you can simplify e to the power of ln, then only you can cut, become 1. So x to the power of negative 1, which means your integrating factor is 1 over x. Then the third step here, multiply your integrating factor back to your standard form equations here. So 1 over x dx dy minus 1 over x times 1 over xy, and right hand side is 1 over x. Then continue, write out our product rule. How will be the product rule formula? It will be d dx vx, which is 1 over x times y. To the right hand side, 1 over x. Then how to get off the d dx, the differential term? We integrate both sides. When we integrate both sides and differentiate and the process of integrate, it will cancel each other. So it will cancel each other, it will give you 1 over x times y here. And integrate 1 over x, you get ln x plus c. So get up to your general solution, which means that we must let your y to be the subject. So to get your y to be subject, your x need to move to the right hand side, means your x you need to time with ln x plus c. Don't just time your ln x, your c at the back also need. Or we accept this ln x ln x plus x times c. So that will be your general solution. And x times c cannot simplify to just c constant because x is variable, c is constant. When you x times c, it's just x times c. Unless you constant times constant, then only is a new constant. It will be okay. So for this, basically is the first step, how we arrange. The important here is how you arrange to the standard form and get your px correctly. That will be your first concept. Secondly, get to your integrating factor correctly. So we figure out, see here, your answer. Then perform our multiple step so that you can get to your product rules. And we see here you integrate both sides to get your solution correct. Rearrange your solution to get y as a subject here. So that's all for this number 3. We move on to number 4. Number 3b. So for the question 3b here, the amount of radioactive substance present at the time t in the days is modeled by the differential equation given here, dq dt equals to negative k cubed. So what's your variable here? Your variable here will be your time and your quantity. So your quantity is the amount present at the time, where k is a positive constant, represent the decay rate. So initially means starting T0, you have 200 milligram. So your quantity here in milligram. And it decreased in 180 milligram in 5 days. Then determine the exact value for the decay constant. Find your k, which correct to 3 significant figures here. Then you find your half-life and correct it to 2 decimal place. So we start with our differential equation here. We rearrange. You can see when you have variable q and t, you just have the unknown q here. T is not present. When your t is not present, which means that this differential equation is separable. Rearrange the q to the left hand side. And dt times it to the right hand side. And we integrate both sides, we get this ln q. Negative kt plus c. So we try to solve it to get to the value of k. So unlock this, it will be base e, then all these become the power a. And we simplify e negative kt plus c, we can times with ec, it gives you the constant ae negative kt. So this is our general solution. We move on to the first information when t is 0. The quantity here is 200 milligram. So 200. So substitute 200 equals to AE0. So we find out the first constant A is 200. Now our equation Q equals to 200 E negative KT. We substitute the second information when T is equals to 5. Q is equals to 180. So from here, we need to find out what is your constant K and read the question. They say they want the exact value, find the value K and correct it to 3 significant figures. So simplify this. So it will be ln 9 over 10 negative 5K. Then K will be 1 over 5 ln. So simplify to the 3 significant figures here. It will give you 0.0211. So the 0 here is not significant. Start with this value. 211 here, only 3 significant figure as the question asks here and require here. Then when we move on to second questions, number 2, they say hence, which means that you must use your k value here to answer what is your half-life. Half-life means your quantity, your timing for your quantity. When is your timing for your quantity to be half? So initially 100 to be half will be 200 to be half will become 100. So your quantity is 100. Find out your half-life. Find out your time. So substitute into our equation. 100 equals to 200 e negative k here and times t. So 1 over 2. Move it one by one. Move the e become ln. And the t will be ln 1 over 2 divided by negative 0.0211. Correct your value to 2 decimal place. So it gives us 32.85. So this is days in the unit. Alright, we see what is important here. The first one is you solve this by separator method. And you integrate it. We see how you integrate to get to your general solution. And starting to find your a value, substitute another information, come up to the final answer of k value here. Then for the second questions, where we can see, can you understand what's your half-life? Substitute your quantity to be 100 and simplify to find your time. Of course, you must use your k that you find from the part 1 here, because the questions already mentioned, hence means you need to use your result to answer this part, the following part here. So that will be our 3b. We continue to our question 4. So for question 4, they're given here 3 points. So find the vector from A to B and vector A to C in the unit of I, J, K. Hence determine whether these two vectors are diagonal. So firstly, when you get the point, we can change the point to the position vector, which is OA, 2i minus j plus 3k. And point B become OB, which is 6i minus 3j plus 7k. And then OC, which is 5i minus 3j minus 1k. So, of course, I can write in 2, negative 1, 3. Or I can write in 6, negative 3, 7 in vector form. But then, for the question A, you have to be careful. You must write your answer in IJK. So although you write in vector form, later on you need to change back to IJK, vector in IJK. So for the first question, to find AB, it will be AO plus OB. So AO negative OA, 2 negative 1, 3. Then OB, 6 negative 3, 7. So once you operate it, you will get 4, and then this is also 4, and then 4. So this answer will not be accepted because they already mentioned in the vector of IJK. So 4i plus 4j plus 4k. Here we have our AB, and we continue with AC. AC will be AO plus OC. So AO negative OA and OC 5, -3, -1. So it gives you 3, then -2 and -4. So in vector 3i minus 2j minus 4k. And hence determines these vector are orthogonal. Orthogonal means 90 degree. Means is it perpendicular? So to test it perpendicular, we need to use dot product. So this part, we need to find out what is your AB dot with AC. So your AB is 4, 4, 4 dot with 3, -2, -4. So result, it will be give you 12 minus 8 minus 16. We get -12, which is not equals to 0, which means this is not perpendicular or not orthogonal. We answer to the question, do the conclusion. We've set out what is your reading here indicate since AB cross with AC, it is not equal to 0. Therefore, AB and AC are not orthogonal. So here we have our first part A, and we continue for the second part B. B is find out the unit vector. So unit vector, it will be the vector over the magnitude, which is normal to the plane containing ABC. So which means that you want the normal vector, unit vector for the normal. To get the normal vector, we need our AB cross with AC. Cross product, we will form out your normal. So I, J, K. 4, 4, 4 with 3, -2, -4. So how many I minus how many J plus how many K's here? So eliminate your I, you get 4, 4, -2, -4. So in, copy paste, in and out, vertically is 4, 3. So 4, 3. Perform your working. Where this one you need to write out what's your AD minus BC. So this is our vector normal. Getting from cross product. So how to calculate its unit vector? We need to find out its magnitude first. For square root x squared, y squared, and z squared. So finally, the unit vector for the normal will be the vector divided by its magnitude. So simplify this. Alright, so simplify it to the form of ijk, not just put in the formula and let it like that. Then question C, they ask us to find out Cartesian equation that the plane containing your point ABC. So your normal already have. So you want the equation of the plane, it will be r dot n equals to a dot n. R will be vector of x, y, z. Normal vector, which is we get here from the cross product AB point times AC. So the point, one of the point here, you can see our question here consists of 3 points. You just randomly take one point. We can take A, we can take B, we can take C. So the point in the position vector 2, negative 1, 3. The point in the vector form. So the point is not in the coordinate form, yeah? Then we simplify this. You can get this one, negative 8x plus 28y, then minus 20z. This is negative 104. Simplify it, as you can see, this is all even number. So, and we can divide it by negative 4. So this will be our equation of the plane in Cartesian form. So now we see what is important here. So at first, when you want to find out the point of A and B, so this is your method AB plus AC or AC plus AO plus OC. So that is method for these two, and your answer in vector. And then to determine whether it is orthogonal, that will be your concept of dot product. And you must show it what your result says here. Your result negative 12, it means it is not perpendicular. You just not simply calculate and let it without conclude out, because we cannot see negative 12. What does your value here means? You must say that is not equal to 0. Your vector is not perpendicular. So that will be your answer. Here is your 4 marks. Then you move on to question B, 5 marks. So 5 marks, firstly, how you find out your normal vector from the point ABC using cross product. Perform your working clearly. Alright, so don't skip your step and get to your normal vector. Then to find out the unit vector. So you want to find out the one unit from here, you must have your magnitude. And unit vector formula will be vector divided by its magnitude and simplify to the simplest form here. Then the question C is asked for Cartesian equation. So Cartesian equation formula r dot n a dot n. So this is our formula. Perform your dot product here, 1 marks. Alright, so we didn't skip this. We better simplify it, show out the method one by one. It will be negative 16 minus 28 and then minus 60. So negative 8x plus 28y minus 20z equals to negative 105. Don't skip the step. Then you simplify it. This is your dot product value. Simplify the equation into the simplest form. So that's all for this. So all is our discussion on this Mid Sem test. Hoping this help you to score better. Alright, so thank you for watching.